Hello guys, welcome back to SRE Demystified series. In this session, I am going to briefly explain about practical alerting, some of the considerations when we consider alerting for practical purposes and primarily reflecting the objectives or the studies or learnings from Google on what they suggest. So there is a chapter on practical alerting in Google SRE's reliability book, site reliability engineering book. I request you to read that. So what is monitoring? Monitoring is essentially looking at various activities that are going on to find out some insightful things, some alerts, some unexpected events, some spikes, etc. And monitoring a very large system is challenging for various reasons, including sheer number of components being analyzed, the need to maintain a reasonably low maintenance burden on the engineers who are responsible for the system. So a large system should be designed to aggregate signals and run outliers. The monitoring system's objective should be high level alert for high level service objectives, but retain the granularity to inspect individual components as needed. Borgmon, the rise of Borgmon, that is how they say in their textbook. So Google came up with their own in-house monitoring system called Borgmon, which is a white box monitoring. Instead of executing custom scripts, for example, to detect system failures, Borgmon relies on a common data explosion format. The data is used for both rendering alerts and charts, which are accomplished using simple arithmetic linear algebra. Metric formats were standardized. An example of an adding mapped variables in Borgmon is showing 25 HTTP 200 and 12 HTTP 500 is like this: HTTP underscore responses map colon code 200 colon 25 404 colon 0 500 colon 12. So they focus on aggregate data collection rather than individual data collection. The storage of the data happens in a time series arena. The service is typically made up of many binaries running as many tasks on many machines in many clusters. Wow! Borgmon needs to keep all the data organized while showing flexible querying and slicing of the data. So they stores all the data in an in-memory database, regularly checkpointed to disk. They have the form timestamp comma value. So you see here an example on various hosts on the x-axis, which means the columns. The rows represent different times. Now minus delta, now minus 2 delta, and then they are storing the values. This is how they typically store a time series for error factors labeled by the original host. Each was collected from labels and vectors. So they have the concept of vectors because they store the data ultimately is implemented in a label set which is called as vector. The key value pairs are stored. What can be different labels? A var can be name of a variable, job can be name given to a type of server being monitored. A service can be a loosely defined collection of jobs that provide a service to users, either internal or external. Zone is location of the Borgmon that performs the collection of this variable. See here an example. The variable is http underscore request. Job is web server. Instance is host 0 colon 80, the port including the port. Service is a web and zone is US underscore or US hyphen west. And the Borgmon also have, sorry for the typo, this is a rule evaluation. So Borgmon also have the concept of rules that helps you do evaluation of data. So the rules run in a parallel thread pool where possible, but are dependent on ordering when using previously defined rules as input. So let's take an example. For a cluster of servers, the rule is like computing the rate of request from each task over here, which is a function called rate that calculate the rate of request every 10 minutes. Then sum of the rates to get aggregate rate. So they have a sum without instance that excludes individuality and factors the commonality. Or an example of an alert rule. See here, creates an alert when an error ratio over 10 minutes exceeds 1%. So you can see here 1 here, and for every 2 minutes it looks at the error rate, and then when there is sufficient issue it throws a alert. Maintaining the configuration. Bogmont configuration separates the definition of the rules from the target being monitored. It also supports language templates. The first class simply codifies. They have two classes of templates. The first class simply codifies the emergent schema of variables exported from a given library of code, such as template exists for the HTTP server library, memory allocation, storage client library, etc. And the second class templates are to manage the aggregation of data from a single server tasked to a global service footpoint. So, a lot of insights on practical alerting. I really request your viewers to look at the reference textbooks by Google on site reliability engineering and the SRE workbook. Thank you. Let's hope to see more videos later.